Alright, hi everyone. So welcome back to this video. So in the series of design patterns, as we have already discussed, there are three design patterns, three commonly used design patterns that are categorized as creational design pattern, the structural design pattern, and the behavioral design pattern. And in the series, we are beginning with the creational design pattern. And the first pattern in this series is called as Singleton pattern or Singleton design pattern that we are looking in this video. Okay, so what is a singleton pattern, or what is a singleton in its own meaning? So as the name suggests, singleton here means single. Okay, this means that we are looking at creating just one instance of an object, one instance. Okay, so you know that in Java or any other programming language, let's suppose you have a class. I'll name this class as hello. Suppose this is a class. You can always create multiple instances of this object by doing hello, new hello, right? And this is going to create multiple instances of that object. But we don't want multiple instances of that object, and we want to restrict the instance of that object to just one. That is, in a runtime, when the class is loaded, you can only create just one instance of that object. Now you might ask a curious question here. Why would we ever need to create just one instance of an object? So here is a scenario for you to just ponder upon. Let's suppose that you have a big application. Let's suppose this is your application. Let's call it a shopping app. Okay, and this shopping has multiple components to it. We'll just use three components maybe in here. So for suppose we can have the let's say cart component that is helping people to add things to their cart. There could be a payment component that is helping people to pay. And then there is a tracking component that helps customer track their orders that they have made on the website. But if you know that there may be multiple different features on your application, but there is going to be a single DB, just one database which is going to store all of your data. Okay, and this data could be about the cart information that the customer has, the payment information, and the tracking information. And all of this is just stored into one database. Right? There's just one database and multiple different places where this database is used. Now suppose that in your application that you have created that has these three features, okay, you are writing multiple different connections to talk to this database. Okay, so you create one connection which is used for the cart information. There's another connection that you use for shopping information, and there's third connection that you use for tracking information. And by the way, there are, let's say, 1,000 customers currently in this moment working on your application or interacting with your application, and there are three different connections that is made to the database. Okay, this in general is a bad design practice. Why? Because we don't need three different connections to the database. The database is single, and the database only requires a connection to do the transaction on this database. And this might cause various kinds of inconsistency in the database. Okay, the database can be loaded too much by one connection that the other two connections are not able to perform their transactions on the database. And I don't know exactly the internals of the database, but this is definitely not an efficient way of communicating with the database. So what you think about is just removing these three connections and having just one connection to that database. Okay, so then you go ahead and then just write one. You just write one programming logic, which is, let's call it a transaction manager. Okay, so this is a component that is going to help your three features that you have on your app, okay, connect with the transaction manager for their database needs. And this transaction manager is then going to manage different queue, it can use internally a queue or a stack or whatever in a data structure in order to manage the requests that are coming from these three features, and then it is going to make the connection to the database and perform all the transactions to that database. Now, I don't want to talk about the design of your application here. What I want to talk about and what I want you to pay attention to here is this particular component, which is the transaction manager, which we have over here. Okay. Now, transaction manager just have to be one in your entire application, and this is where we can utilize something called as Singleton. That is, this transaction manager class, if you have in your transaction manager class, if you have in your code base, source code, should only be instantiated one time, and it should not be instantiated multiple times, because if it is instantiated multiple times, it is going to end up having multiple connections to the database, which kills the purpose of having a singleton. So this is a scenario where you can use a singleton pattern very well. So yeah, this is one case, this is one thing for you to visualize. Why do you want to a class in your Java or in your C++ or whatever object-oriented programming you use to have just one instance of that class. Okay. Another could be, let's say, a very well-known such as log manager. Okay. So let's suppose you have a log manager that is going to log the information about the various features that is currently running in your application. And the thing is, there has to be just one log manager. There cannot be multiple log managers, because all the activities are going to managed by just one log manager. So in this case as well, you would want to have a singleton for that log manager. Okay. So this is the reason why we use singleton pattern and singleton. So now that you know that singleton pattern is a single point of contact. Okay, we can also name it as global access. A singleton has to be available globally throughout your runtime. And the second one is only instantiated one time. Okay, so this is the reason why we use this is the why we use singleton pattern. Okay, and this is also kind of a definition to the singleton that I have already explained. Okay, so this is what is singleton. Okay, now let's go ahead and try out a code example of how do you create a singleton. So singleton is not a special implementation, Okay, any class that you have can be converted into a singleton, given that that class is not instantiated with constructors arguments. If your class is not created with or instantiated with constructor arguments, that then you can create any class that you have into a singleton. Okay, and you have to follow just simple steps in order to prevent the instantiation of any class. So for suppose let's suppose I'll just also show this in the IDE in a short while, but just writing the code here. So let's suppose you have a class called as hello, and this class has one method, which is a public method, public void say hello. Okay, and this is going to do the sysout of hello world. Okay, so this is my class. If I want to use this class in a code, I can simply do hello var equals new hello, and this is how I can use the class. But I want to prevent the instantiation of this class. So in order to have just one instantiation of this class, that is, you can only execute this block of code just one time, you have to follow few rules, and then you can convert any class into you can create any class into a singleton class. So let's hop back to our IDE and see how you can create a singleton out. Okay, so I have a public class hello, And as I said, I will also be having a public method to say hello to the user. Okay, so this is my class and I want to create this class into a singleton. So the rules, the simple rules that you have to follow to convert any class into a singleton is threefold. First, you have to declare the constructor of this class as private. So let's go ahead and do that. Okay, now that you have declared the constructor of this class as private, you cannot actually instantiate this class anymore. So for suppose if you have, okay, so for suppose you want to use the hello class from a different class in your project. So for suppose I have created a class called test and I want to create an instance of hello. This is not possible because we have declared the constructor of the hello as private. So that's the first step. The second step is we want to have a variable that is going to hold our class object, instance object. Okay, and we have to declare this as private static variable. So let's go ahead and do that. Cool. So now we have a private static hello variable, and then we also have the private constructor of this class. Now what we want to do is that we want to give access to the user to this instance object whenever someone asks for it. So I'll just create a method called as getInstance method that is going to return this instance variable to me. Okay, so now with this instance method I can get the instance of this class hello. But if you see that the instance is not initialized, you also have to initialize this instance if this is not if this is not initialized, or is it if it is set to null. Awesome. So now we have a get instance method that is going to return us the hello class, and this is going to prevent multiple instantiation of the hello class. So if for the first time if the instance is null, it is going to create a new instance of the hello class, and then it is going to return us that instance. And since we have declared the constructor as private, there can be no more than one instantiation of the object which has been handled by the getInstance class. So I'll go back to my test class and I will change this code to something like this. Awesome. So now I have the hello class, and then I can use all the business logic and the method that are present inside of it. Awesome, it prints hello world. So this is the concept-wise the implementation of the implementation of the singleton is done. You have to follow three rules. One, declare class constructor private. Rule number two, create a private static instance variable. And third one is give access to instance object via static method, public static method. And if you follow these three rules, you can convert any class to a singleton. Alright, that's done. So singleton implementation is done. Concept wise it's okay, it's finished. But now there are some problems that are related to this implementation, specifically in Java programming language, and let's discuss about that. So one of the problems that you can face while using the implementation of a singleton in that manner is the race condition problem. So those who don't know about race condition problem, I highly encourage you to go to Wikipedia and read about race condition problem. It's a very popular operating system computer science problem that you should know about what race condition is and how it is a big problem. Okay. So as far as I discussed that this is the basic concept implementation of a singleton in Java programming language. Now let's discuss about what the race condition problem here will imply. So the problem is pertaining to this block of code. Okay, suppose that you have two threads running in your application. Okay, these are two independent threads, they are not related to each other and they are running in your application. And both of these threads simultaneously calls for the getInstance method, which is like hello dot getInstance. Okay, and this also calls for hello dot getInstance. Okay, and they both calls it simultaneously almost at the same time. And for suppose the thread 1, when it calls the method, they both enter into this block of code at the same time. And they start executing from line 1, 2, 3, 4. Let's call it line number 1, 2, 3, 4. And they both started executing this from line number 1, 2, 3, 4. And for suppose that the thread 1 was at line number 1 over here, and then it went to sleep. Now this thread has become dormant, and in the meanwhile thread 2 continued its execution, and it created an instance of hello class, and it is now using an instance of hello class. Now thread 1 got back from sleep. Now it started its execution again, and it continued from line number 2 again, and it started executing it, and then it also calls this line of code, which is line number 2, and creates its own instance. So now this x1 hello is different from the hello which the thread 1 is using, which is x2. And this is a major problem in multiple places, in multiple ways, because first of all, this is not what the singleton is made for. Singleton is made for having one instance of an object that you have. So thread 1 and thread 2, both of them are using different instantiation in the runtime of a hello object class. We want to prevent that. We do not want that that way. We want it in a way where both T1 and T2 is having access to the same instance of the hello class, which may be either x1 or x2, but not two different ones. This is very big problem also in terms of resources. If your hello instance is too expensive to create, let's suppose it requires thousands of database connection all at the same time. I'm just supposing it might not be possible, but let's suppose it's possible that hello, when you instantiate it, it requires multiple database connection, which is quite expensive and time consuming. Both thread 1 and thread 2 is executing the line number 2 times, and it's taking a lot of time, also taking a lot of memory space, and it also kills the purpose when they have two different instantiation of the same class of hello. Okay. This is what is called as a race condition, and it is a big problem at many places, not just Java programming. It is a problem in operating system also. So I highly encourage you to read about race condition. Okay, so how do we prevent the race condition from happening, and how do we ensure that this block of code, and more specifically this line of code, gets executed only once, even if two threads are accessing them simultaneously? There is a concept called as mutual exclusion, which simply states that when one block of code is being used by one thread, it has to be locked, and other threads cannot use this block of code. And how do we ensure that? In Java, if you want to lock a particular thread of block of code and do not want the other thread to access it at the same time, we use something called as synchronized declaration. Okay, so let's get back to our code and use the synchronized declaration to convert our get instance method and actually mutually exclude it from two different threads ever simultaneously executing this block of code. Alright, so here what I'll do is I'll just declare my method with a synchronized modifier, and this is going to prevent two different threads executing line number 11 till line number 14 simultaneously. Okay, so this is done. So we have actually solved mutual exclusion over here. It was quite simple, but it's Java programming language, and it again have some caveat of using synchronized, using the word of synchronized. One of the problem of using synchronized word is that it is again expensive. Okay, if you look at line number 11, which is checking whether the instance is null or not, and also creating on line number 12 an instance of hello class, it is computationally very expensive on threads. Threads would have to wait, even have to go to sleep sometime when the synchronized keyword is used until another thread is being working. So in general, it is quite computationally expensive to use synchronized keyword over here. And if your hello class is big enough that requires a lot of time to get instantiated, then in that case synchronized is actually adding an overhead on the computationally expensive instantiation of the hello class. So synchronized is a good strategy to use, but it's not always the best strategy to use because it is computationally expensive, and if your singleton is big enough, it is not the choice. So what we can do here in order to prevent using the synchronized method? So the synchronization problem. How do we deal with the synchronization problem? The simple way to dealing with synchronization problem, which is basically the problem of this block of code, which is if instance is null, then I need to create an instance with new hello, and then I'm going to return this. So this block of code, when you do with synchronization, becomes computationally expensive for threads in order to check again and again if an instance is null. Also at this point, if any thread go to sleep or becomes dormant, it's like, you know, synchronization has to happen again. It has to block the code again next time when the thread is locking this block of code. So the simple way to solve this problem is to just having something called as eager instantiation. So what you can do instead of having this check is that instead of checking whether the instance is null or not, you just simply go ahead and create the hello class itself on the top on line number 8, and you simply remove this. Now that check of if the instance is null or not is not taking place, and you are just simply returning the instance. But as I told earlier also, that instantiation of your hello class could be expensive. And if it requires, let's say, a lot of memory resource allocation, then in that case, line number 8 does not make any sense. Also, if you go back and we do something called as eager instantiation, let's suppose we take eager instantiation as our solution for solving the synchronization problem. The problem it is going to bring us next time is that unnecessary object instantiation, even if you want it or not. Okay, so if you do eager instantiation, it is going to do the unnecessary object instantiation even if you want it or not. This is a major problem. If you load your hello class during runtime, it is also going to instantiate a hello object instance during the runtime. And as I told again and again, if your hello class is too expensive to instantiate, then it is going to have the memory waste and also the time waste. Both of these resources will be unnecessarily be done. So we only want to instantiate the hello class when we actually requires it, when we actually call the get instance method, not before that. So how do we handle that kind of thing? So we handle that kind of thing where we want to prevent the instantiation of any object when only we want it and not when it is loaded into the runtime memory, is with the help of something called as lazy instantiation, sometimes also called as holder instantiation. So how do we implement this? Let's go back to our code and find. So in our code, instead of having the instance variable declared within the hello class, we are going to create one more private static class called as lazy loader or lazy holder, whatever. Okay, so this is what is called as lazy loader or holder class, and this only instantiate the hello class only when lazy loader is called during run, not before that. So when you call the get instance method, only then the lazy loader class is loaded into the runtime memory and it creates an instance of hello class, and this is around the same time when we have also called the get instance. So this is how we return the lazy loader, and this is completely mutually exclusive, and two threads are not going to have that race condition problem because the instance is only instantiated one time. And also it solves the computationally expensive problem of synchronization that I have just mentioned about in the previous slides. So this is the final implementation wise, the best implementation of a singleton. If you want to create any kind of class into a singleton, you use this kind of implementation. And you can, I'll just comment out the section of the code which is the user code. This is your business logic that you are putting, and this is the logic that is used for the creation of any class into a singleton. So this is how the singleton pattern is used. And also think about doing the same stuff inside of Java. So if you use enum class inside of Java, for suppose I can have a enum, okay, call it hello2, and you can declare any method inside of it. Let's suppose you have public void say hello. So you can have something like this where you have an enum that has a method called as say hello, and enums in Java are only created one time, so you cannot have multiple instances of an enum class inside of Java. So this is also a way to create singletons in Java. So whichever methodology suits you best, you should use that. And but this particular way of creating singleton in Java is the default way to create singletons in Java. So I hope you must have liked this video, and if you'd like to check out a full write-up on the singleton pattern, you can reach out to my blog and read this entire thing on your own, and also try to have a read through it and implement it for your own use cases. In the next video, we are going to talk about something called as builder design pattern, which is next in the series and a part of creational design patterns. Until then, stay safe and happy coding. Bye bye.